Hi everyone, we are starting our open day. Before we start, can you please listen carefully, everyone who is going to show you some presentations, because in the end we are going to have some quiz and some gifts after it. Okay. Also, if you would like some water, please take it from the table. Okay. Okay, welcome everyone and thank you for joining us today. So let's start. My name is Polina and I bring with me over a decade of experience as a Java developer, specializing in both enterprise and platform solutions. Over the years, I worked in different projects and gained experience in solution architecture and platform engineering. I've played a team and tech lead roles and participated in various mentoring programs as a mentor, contributor, and run coordinator. In addition to my main workload this year, I'm embracing the challenges and opportunities of my role as the head of the MJC School. I'm excited to be here with you all and welcome to MJC Open Day. And I hope this day will be engaging and enriching for all participants. Now let me tell you the story of how the MJC School was founded. It all started with the first mentoring program 10 years ago, and it was a hit and it ignited a spark of inspiration and success. Many people were inspired by the experience gained from the first mentoring program, and this marked the beginning of the development of the huge area of mentoring programs. As the field grew, more and more people joined and more mentoring programs were created. It turns out that there are many people, each bringing their own unique skills and shared passion for learning and knowledge sharing. This growing momentum led to the formation of an active community. And within this large community, the group of people was formed, united by firm principles and ideas that are now laid down in the foundation of the MJC School. So in a short time, the MJC School was created. Let's dive into the principles and ideas that shape the MJC School. Our core mission is all about building bridges through learning and knowledge sharing. We focus on strengthening personal connections that lead to growth and encouraging continuous learning and empowering individuals to share their knowledge and skills. Our goal is to create a supportive and inclusive community that thrives on collaboration, creativity, and innovation. These values are the backbone of our program and guide us in everything we do. As we continue to grow, one thing remains clear: the importance of staying connected. Open communication is the glue that holds us together. We value every voice in our community and encourage all members to participate and contribute their insights to the MJC School. This helps us to shape the future of our school together. We also invite everyone to try on different roles within our school. Discover new talents, explore new interests, and most importantly, you can have fun doing it. Together, we innovate and improve, ensuring that MJC School remains a dynamic and welcoming place for everyone. Let's inspire and be inspired as we continue to build, learn, and grow together in the MJC School. Thank you for being a part of this incredible journey, for everyone who joined us offline and everyone who is watching us in the stream. And now I want to say thank you in advance for everyone who contributed to this event and everyone who prepared and helped us to be here today. As you know, maybe you don't know, but MJC School has different locations. And right now I'm going to invite my head of Uzbekistan MJC School, Ilyor, so he can continue. Thank you.
Um, Hi everyone, let me introduce myself shortly. My name is Elior Khojhanov and I'm an EPAM lead software engineer, and also as Polina mentioned, I'm a head of MJC School in Uzbekistan. And today I want to tell you more about the school and how the processes go. So let's head right into it. Let's start with the contents. I will firstly introduce a little bit about the school itself. The school itself, the course is split into different stages. So I'm going to tell you about each and every stage and what you're going to learn in it. Then I'm going to tell you a bit more about the learning process. So how the actual learning goes, what resources the school provides. And then for our more experienced Java engineers here, we also have an option of mentoring and contributions. So if you don't want to learn in the school because you're too experienced for it, would be appreciative if you thought about contribution or mentoring. And we'll finish off everything with contacting me and different QRs to different resources. Well, what is MJC School? Thank you, Polina, for introducing it, but this time we're going to be talking more about the details. MJC School is a free community-based Java school for everyone, no matter the age, occupancy, residence. So anyone who is interested is welcome to the school. It has different attributes. It's completely open source. It's online and free. It's self-paced, so you're going through it as the time goes for you. You don't have to rush. You don't have any deadlines. It revolves around community support a lot. So we're expecting that in MJC School, we're going to create a community where everyone helps each other, where students communicate between each other and with mentors, and everyone is very helpful towards each other. At the latter stages, MJC School has production mentoring, which means that you will get your personalized mentor that's going to prepare you for the production and teach you way higher complex things. They're going to prepare you for potential first junior job, which is our next point here, professional opportunities. The top students are going to be considered for a hire. We are always searching for talents, and graduates of MJC School is definitely the place to find them. Let's see what you get if you apply for MJC School. You're going to get an access to a variety of learning materials. You're going to get access to code tasks with automated checks. There are a lot of them, and the automated checks make the learning a breeze. You will get support from experts in the field. We have a lot of experts from EPAM that are mentors of MJC and different others from other communities that help you out any situations that you need it. And you will get a personalized mentor in the later stage that will help you completely with your production preparation or your first junior job, for example. Let's talk through the stages now. It's divided into 5 stages. So stage 0 is for complete beginners. So this course is beginner friendly. You will learn about computer science, what Java is, about JDK, JRE, and you're going to learn the basic Java syntax. And after that, you will be able to write a simple console Java application. Stage 1 is core, is where you deep dive into Java itself. Java core includes different topics like collections, stream API, Java input output, concurrency, and after this stage, you'll be able to write more complex applications in Java. Then we have stage number 2, which is all about web. You're going to start writing applications using Java servlets. This will allow you to write web services in Java. You will be also able to build your applications and version them using Git system. The stage 3 is already more complex stuff. It's modern frameworks like Hibernate and Spring. and you will be able to do the things efficiently using the modern frameworks that we usually use in our production at work. And stage 4 is all about enterprise. This is your final preparation for your job. Things like CI/CD, advanced REST, AWS deployment, security, authentication, authorization, all of that. And at the end, you will be able to develop your own production-ready application and able to deploy it to cloud. Let's discuss a little bit more about the learning process and how it goes. Our main communication channel is Discord. So Discord has different channels for off-top topics. It has channels for every stage. And for example, you can communicate with your mentors through Discord. Those links, feel free to take a picture now, or at the end, you will be able to access them too. And they're always available on the webpage too. So right now, feel free to do it. Feel free to wait for later. We also have our Telegram channel. Maybe some of you saw the invitation to MJC School from here. So please, we encourage you to follow it, not to skip any events like that or updates for MJC School later on. I'm gonna hold it here for 5 seconds in case anyone wants to take a picture. But again, the last slide will have all of the links. The next thing here is GitHub. All of the source code and learning material is located in GitHub. So here you have a link to GitHub, but of course, where there are code tasks, you can see a bunch of repositories. We'll talk more about that in a minute. And the next thing is AutoCode. AutoCode is an EPAM developed tool. This allows to process those automated checks. So if you write any task, if you implement it, you don't even need a mentor to take a look into it and, for example, give you a feedback, because you're going to get an automatic feedback from the tool if you did it correct or no. And let's take a look at one very simple example. This is the very first example in the MJC School. Actually, you're just supposed to write hello world in the application. You just clone the repo, you write the code, you let AutoCode run the automated checks. Of course, this is just the start. So let's take a look at one of the latter stages tasks. Here you will already have a system developed at this point, and you will need to, for example, migrate everything to Spring, and then introduce a new entity and introduce some CRUD operations using Spring. So tasks are very interesting and they're not very simple. And then we have our YouTube channel that has a lot of videos about different Java topics and not just Java. For example, there are some that teach you to work in IntelliJ IDEA effectively, for example, and different, of course, Java core topics, Spring, Hibernate, and everything like that. So feel free to subscribe to it too if you want. And here are the slides for our more experienced programmers, if we have them here, more Java programmers. Oops. Siri.
Okay.
Sorry. If you want to be a mentor, I'm going to tell you about the mentor responsibilities. As a mentor, you need to understand the material that you're teaching our students. You have to assist them in learning. If they have any problems occurring during their tasks or just questions to support. Then you have to track student progress. You have to check their task result in the latter stages, as latter stages are very complex applications. So you will have to check it manually. You have to prepare them for production, give them the experience that you have, and conduct light talks, which is optional. You can gather a meeting of multiple people or an event like that and talk about some Java topic. And if you don't have enough time for being, for example, a full mentor, you can still contribute at your free time. You can just join the Discord chat and see maybe you have any questions that you can help with. We have our task flow and big source code that needs maintaining, so that would be really appreciated too. If someone is interested, you could conduct roasting battles. It's a very interesting process where you gather up multiple students and you basically ask them quiz questions in a very rapid succession. And of course, we have our YouTube channel. So if you want, if you have a will for it, you could record lectures and we would gladly include them in our YouTube channel. And thank you, everyone. So here are all the links that you saw throughout. So right now you can take a take a photo of them, or maybe if you want the first one on the left right here, it's a website for MJC, and it has all the links. So you can just take this one too, or take a picture of everything. Yes, of course, we can share it. Yep. Thank you. That's a good point. And that's actually it for me. So I'm gonna give it to Alina now. Oops, not this one.
Okay, 1, 2, 3, just for checking. Cool. So, hello everyone. It's real a pleasure for me to see you all today at our first open day in MJC School in Uzbekistan. And yeah, and I'm going to tell you a little bit about how you can elevate your IT career with us with EPAM, and which kind of ways exists to join us for today. And yeah, my name is Alina. I am a member of HR team in EPAM Uzbekistan, and I have been working there for over 3 years. Yeah, and that's all about myself. So, and who we are, I mean, what do you know about EPAM company from your side? Can you share with me any kind of ideas? What came into your mind when you heard about EPAM? Global organization. Something else? Business trips. Okay, thank you, Paulina. So, any more ideas?
It's abbreviation.
Mm-hmm.
Programming for America.
Oh, we have advanced level. Okay, yeah. Yeah, it is really abbreviation. From the beginning of the company, it was like we can, it can includes several words, effective programming for America. And our journey was started in 1993. It was started from 3 developers, one small office for the time, even maybe some co-working space, and one client. And it was founded by 2 classmates, Arkady Dobkin and Leonid Lozner. And the first offices of EPAM was located into 2 different continents, in USA and Belarus. So, and what we have now, we have global IT organizations with lots of opportunities for IT specialists, with more than 58,000 EPAMers around the world, and our offices located in more than 55 countries and regions. So why people around the world choose us? First, we provide limitless opportunities limitless opportunities to grow for smart, self-motivated, independent individuals. On our learning platform, all e-commerce has access to different trainings, comprehensive learning models to enhance both of their soft and hard skills. And with us, you will able to work with high professional colleagues from every country around the world. I think most of countries around the world. You will able to work with world-changing technologies and share your expertise with other colleagues. And I can share you the list of our customers, unfortunately, because I have signed an NDA, but I can say that most of them you can find in the list of Forbes Global 2000. And also our unique culture helps to create equal professional environment for everyone, and our employees can manage their work schedule and work remotely from home with comfortable atmosphere. So also we have 2 offices in Tashkent, and this year our local office turned 5 years old. During this time, we can proud of a list of achievements such as rapid growth. We started from the team with 7 employees, and now we are more than 500. Many interesting corporate events were held for that period, and many communities were created, and much more. And we also launched IPAM Campus, which for many was the beginning of career in IT, of career in IPAM. So, and about IPAM Campus, here you can find some numbers, how many courses were we have, how many participants completed or even in the process of completing these courses, how many years of expertise we have, and how many trainers, of course, talented trainers who leads our participants through their learning experience. We have lots of training directions and actual programs that you can join even now. Java, .NET, JavaScript, Node.js, and all actual technologies that we have in our company. And how you can start your learning in our training center. First of all, of course, today the main theme is MJC School community, and through such kind of community, you can have opportunity to receive more than basic knowledge about technology, to receive like the foundation for your future learning, and then to join our training center, complete some program, communicate with our mentors, and enhance your tech and soft skills together with a mentor, and then apply for a job in IPAM. Where you can find information about our campus, of course, we have our site. You can visit it, campus.ipam.uz. There you will find materials for self-study, interesting tests if you are not sure what kind of direction you can choose in IT sphere. Soft skills and English you can improve through our materials, technologies overview, and some success stories. And here is a photo of Emil. He is our EPAMer, and he starts his journey from EPAM campus. And it was really great opportunity for him to change his career. And now he is, Sergey, can you help me? Emil is senior or middle specialist? Already senior specialist, yeah, for last 2 years, if I'm not mistaken. So explore our events with us. The same site, you can find lots of wonderful photos, lots of registration links to the events that you can participate as a visitor or maybe as a speaker, as contributor. And follow us in our social media. Here you can see a QR code to IPAM Uzbekistan page, IPAM Campus channel, and IPAM Campus channel in YouTube. So, and I think it's all from my side. Thank you. Так.
Неправильно. Так. So, hi again, everyone. You already know me. I don't have to introduce myself. And today I want to talk about one very interesting topic in Java, at least for me, it's very interesting, which is called synthetic threads. It's also referred to as virtual threads, which I'm going to be calling it in this presentation. So let's get right into it. Let's see what we're going to cover today. I'm going to start with a bit of intro, and it's going to be a brief introduction into Java language itself, because I know we have some newbies here. So maybe that would be interesting. We'll talk a little bit about multi-threading and how it works as basics. We're going to discuss the limitation of traditional multi-threading, and that leads us into introduction to virtual threads. We're going to cover some practical examples, compare the virtual threads and system threads. We're going to take a look at one real-world use case, and then we'll wrap up, and I'm going to be happy to answer all of your questions on this topic. So let's start with the very first thing I want to tell you about Java. What Java is, maybe you guys don't know, it's a very strong language. It's a powerhouse of a programming language. It's object-oriented, which means you can write very large and complex applications with it and still keep them structured. It's platform independent, so you can write it once and run it everywhere. It's extremely high performant, which makes it so good for enterprise applications with very high loads. And it comes with multi-threading right out of the box, which is our topic right here. And you might think Java is that old, stable language that doesn't improve that much. And that was true in the past. For example, you can compare version 5, 6, 7, 8, and there is a 5-year difference between one of them, and then 3 years difference between one of them. But that's not true anymore. You can see that every year multiple versions are coming out, and this is bringing a lot of features into Java, which is making our code way better. It optimizes everything and makes it maintainable, readable, and keeps Java up to standards of the programming language right now. So let's take a look at one of the recent milestones in Java journey. This is Java 21. Java 21 is our latest long-term support version. It introduced features like synthetic threads, sequenced collections, record patterns, pattern matching for switch, code snippets. All of those are really cool features, but today we're only going to be looking at the first one, virtual threads. So for those, again, who don't know, let me try to explain the multi-threading concept in simple words. So you can run your application as a single thread. Imagine of it as one worker doing all of the tasks. But modern applications, they don't really work like that anymore. Right now, you have multiple threads. It means multiple workers doing different tasks at the same time. This allows your applications to be highly performant and process everything in parallel and make them very responsive. Let's take a look at it more from a CPU perspective. You have your CPU, and right now most of the CPUs are multiple core. So for example, here on the left, you can see a 4-core CPU, and every CPU has 2 threads, which means with this CPU, you can process 8 actions simultaneously at the same time. Let's take a look from a Java perspective. In Java, you can create those threads and run tasks on them. So how it works inside the Java, when you create a thread, it creates platform thread. Platform thread is created in Java itself, and then this thread requests a thread from OS. And there is a one-to-one mapping. So for example, imagine you create 200 threads in your Java application. This is going to request 200 threads from your OS. And well, this might be a bit problematic, but we'll get into it in a bit. So let me show you a simple code example here. Let's see if it switches properly. Let's do it like this. Yep, we have a very simple example here to show you guys how multi-threading works. Here you can see a simple piece of code that just prints out numbers from 1 to 5. And if you run it sequentially with only one thread, what's going to happen is you will get an output of 1, 2, 3, 4, 5 from one thread, and then 1, 2, 3, 4, 5 from another thread. But multi-threading is such a concept that tasks run in parallel, right? So let's take a look at it and run it. So because it's a multi-threading application, you can see that we have 1, 1 from both threads and then 2, 2 from both threads, which shows that they're actually running in parallel. And here you can also see that it comes as 1, 2, and then it comes as 2, 1. They're actually parallel, so you don't know which one of them is going to happen first. This is for the OS to decide, as this is an OS thread. Okay, after this basic example, let us look at the problems that this might create. Let's take our case of creating 200 requests again. Let me share it again. Imagine you created 200 threads. Well, each OS thread consumes a significant portion of memory. So your resource consumption is very high. The larger the number of threads, sometimes in an application, you might have way many more than 200, well, your resource consumption is going to be very high too. Because of this resource consumption, you can have scalability issues. You can't create threads just because you want to. You have a limited number to create, or else the performance overhead is going to be too big. And there is also a problem of context switching overhead, which I'm going to explain in this chart below. So let's take a very simple example. Imagine your CPU has only one thread, right? That's not the case in reality, but we'll explain a little bit more. If you have one thread and you submit 2 tasks to it, well, what a thread does, it works a little bit on the first task. Okay, where's my mouse? It works a little bit on the first thread, then it works a little bit on the second one. Oops. It works a little bit on the second one, then switches back to the first one, and so on and so forth. This is all good because all of the tasks are getting in their execution time. It doesn't mean that the task B is just going to stall, right? They're both getting executed. The problem comes in this switching. For your physical thread to start doing another task, it needs to switch. And this switch is relatively a long time, which means instead of using your precious CPU time to compute, you're basically just switching your threads. Well, all of those problems might be resolved with virtual threads. This is going to be your introduction to virtual threads. Virtual threads is just one more layer on top, and there are 2 key concepts here. You have a concept of carrier thread. Carrier thread is those same platform threads, but now you have a way fewer number of them. So for example, imagine just 16, right? And you can't create 200 of them. This is a fixed number. So imagine you have, or in this case, you have only 8 of them, right? And when you create a virtual thread in an application, it just creates an object in the heap memory, which is a virtual thread. And then those virtual threads gets executed on those platform threads. What this means is a couple of things. First, no matter how many virtual threads we create, we're still going to have a fixed number of OS threads. And if you remember, all of the problems were with OS threads. Context switching problem is also fixed because mounting those virtual threads onto platform threads and unmounting them is a very quick process. It's way quicker than doing a context switch between threads. And on top of that, your scalability issues are also resolved because OS threads are very heavy, but virtual threads are extremely lightweight. You can create millions of them, and if you have enough memory, your application is going to be able to handle them. But the difference is platform threads and OS threads were managed by OS, but virtual threads are completely scheduled and managed, and the whole life cycle is managed by JVM. So it has its own advantages and disadvantages, which we're going to discuss later. So let me show you a simple test here of for example, let's take a look. I'm going to explain this code in a bit, but first I have to make you see it. Okay, so here we have a piece of code. Let me comment this part. Here we have a very simple piece of code. We have 10,000 tasks. I had to fix it. And those tasks are very simple. They're just gonna imitate a blocking operation. For example, each task is just to sleep for 100 milliseconds. You can imagine this as a call to the database or call to a website or a different microservice, right? Well, let's try to test it out with 10,000 different tasks. And here, those are our traditional pools, traditional threads. We're gonna create 200 of them, and let's try to run it. And at the very end, it's going to print the stats, for example, how much time it took, how many system threads it created, and how much memory it used. So let's take a look at the output. It took us 5 seconds. It created those 200 threads, as you can see, because, again, we requested those platform threads and we requested it from the system, and you can see the memory. Well, memory is not really accurate here, but that's all right. Now let's try the same case with virtual threads. Let's just replace. As you can see, this is just a 1-line small change. And let's run the same exact code. And we can see it's already done. 300 milliseconds compared to 5,500 milliseconds. Well, that's a large difference. We can also see that the peak thread count is very low because our virtual threads, they don't create any new threads. They just reuse the ones existing, which are called carrier threads. And the memory used is very low too. Now, if I want to try it with 100,000 tasks, well, with platform threads, it's just gonna rise exponentially. Well, it's gonna be 50 seconds. But let's try the same scenario with virtual threads. It just took us 746 milliseconds. Here we can, of course, see our memory used has grown because every virtual thread is a Java object. Well, we created right now 100,000 Java objects in the heap, so they do take up some space. So let's take a look at the, let me start from the same place now, play from current slide. Let's take a look at our results on the presentation page. With 10,000 tasks, it's the same thing as we saw here, but memory is a bit more accurate here. 200 threads used, 5 seconds for platform threads, and 67 megabytes used for platform threads, as they take up a lot of space. But with virtual threads, it's extremely quick. The thread count is low, so OS threads aren't that many, more of them are created, and memory used is also extremely low. Let's try, this is an output for 100,000 tasks. As you can see, our virtual threads are doing extremely good. It's just the memory that's rising because you created 100,000 of them, right? But platform threads here, you can see they took more than 50 seconds. So they're not really scalable. You can't just create a lot of threads and just hope that it's all gonna be all right. But with virtual threads, that's basically not a problem. Okay, let's head over, let's discuss what are the real use cases of those virtual threads, because we talked about the test application, but what is it in reality? In reality, they actually have a lot of applications. For example, web servers, microservices, database-intensive applications, API gateways, aggregators, Internet of Things, real-time data processing, web scraping, data collection, message brokers, and event processing systems. All of those, they have something in common. They're all very highly concurrent. So our real applications, they're receiving 100 calls per second. So it has to process them simultaneously. And on top of that, they all have input-output operations. Because virtual threads are very good because they don't get blocked during I/O operations. I/O operations is just accessing the web, accessing another server, accessing the database, writing into a file, for example. So this is all talk. Now let's take a look at our real scenario. Let's imagine that you want to train your large language model, your own language model with machine learning. You need a lot of data for that, right? For example, you decided to web scrape it from Wikipedia, let's imagine, right? That's what I took as my real use case scenario. You're scraping the data from Wikipedia to feed it into your LLM. So let me stop sharing again. Let's head into a code. So I wrote a very simple web scraper right here. And you can see, let me explain this code just quickly. You can see that it requests the Wikipedia website. It's going to request one article, which I put as a seed artificial intelligence. So at the start, it's just going to request this article. Then after that, it's going to recursively request new articles. How it gets it, for example, it got the first article, it retrieved all of the links right here from this article. So, Wikipedia articles, they have a lot of links. And then it started searching through them too. So that way we're retrieving a lot of different Wikipedia articles here. And then it writes them into a file like this, all the paragraphs. So this is a ready data to feed into our LLM, for example. Why this scenario is so good is because we're having so many tasks created, right? You have so many links in Wikipedia. So imagine at some point you're going to have 100,000 of threads running. And for platform threads, it's a horrible situation. And there are a lot of blocking operations too. So each of your thread is just going to get blocked. But virtual threads, they don't get blocked, and they're infinitely scalable if you really think about it. So let's take a look at those results from the run. Here you can see at the very start, I ran it for 10 seconds, my web scraper. In 10 seconds, typical platform threads retrieved 300 articles. With virtual threads, it was 330. It's only a 10% difference, you might think, and yes, that's not a lot. But virtual threads really excel when there are a lot of them. And well, 300 threads is not that much. Let's take a look at 60 seconds. 60 seconds and you already see a way larger difference. 50% difference, because in 60 seconds, there were already way more virtual threads. And again, all those problems with scalability issues, those context switching overheads, they all came into picture. And that's why you see such a big difference here. But now let's jump into 5 minutes, and the difference is already ginormous here. It's almost 3 times. So in 5 minutes, the platform threads retrieved 14,000 articles. But virtual threads managed to retrieve 37,000, and that's such a big improvement for just one line change. And let's take a look at the graph here. It's very simple, but it shows that at the start, those lines are pretty close up, but the more the time goes, the larger the difference is. So it shows that virtual threads really excel when there are a large number of tasks in the picture. But of course, as everything in the world, virtual threads are not a silver bullet. It doesn't mean use virtual threads, forget about typical threads. No, it's not like that. They're not really effective for CPU-bound tasks, as no matter if you use a virtual thread, it's not going to add you more physical threads, right? You can't download more CPU. It can lead to resource exhaustion because you can create millions of them. Well, you create a million of them, it already takes 1 gigabyte of RAM. Well, if you overuse them, that's going to be wrong. Debugging is going to be more challenging because debugging concurrent applications is already pretty hard. But here you add a complexity of such fast threads. Well, the complexity of debugging is going to increase too. It requires Java 21, which, as if you guys don't know, but most of the production applications still have 17, 11, or even 8. So yeah, 8. It may introduce subtle concurrency bugs. Again, it's very, very quick. So you're going to catch your synchronization issues or concurrency mechanisms written wrong very quickly. It has more complicated monitoring and observability because most of the tools are just used to traditional threads, right? So introducing a new thread and current tools for observability, they're not really supporting those threads. And you also have less control over thread priorities and scheduling, as everything happens in JVM itself and not in the OS. And OS is basically the old way, it's already established, but JVM is a pretty new way. So soon, of course, a couple of them are going to improve. For example, people are going to start migrating to Java 21. Monitoring is going to start supporting those threads, and maybe JVM is going to provide us more tools to control the priorities. But for now, it is what it is. It's still a new feature, and I think it's really, really cool anyways. Well, thank you, everyone. Now it's time for your questions. So any questions you had for the topic, please feel free to ask.
Have you tried with another type of executive service, for example, cache thread pool or something else?
Yes, of course. Right now, it's actually still, you really can't use the cache thread pool here because you're still creating 100 threads, right? You're still going to have the same problems. It's just with virtual threads, you can create that many number of them. So
Virtual threads are similar to the cache thread pool because of it's creating another thread. If we have more tasks, it will create another thread. Cache thread pool also creates another thread.
yeah.
What's the main?
The difference is the cache thread pool is going to create a typical OS thread. And OS thread is a problem. They get, again, we discussed those 3 issues with traditional threads, right? They're going to get blocked. And even if you create 100 of them, let's imagine, because you can't create millions of them, right? They're just going to create million OS threads and it's just going to fail. The biggest difference is virtual thread doesn't trigger a creation of an OS thread. So if you use the cache thread pool, it's still going to create those OS threads, and those OS threads, again, had those problems. For example, it might have it, yes, exactly. It might have it. But to be honest, in our situation, cache thread pool and our thread pool, it also caches those threads, you know? It doesn't create millions of them. It just created 100 of them and it reuses it. So for example, the way thread pool works in Java, you created it with executor service and it has 100 threads, right? When you submit tasks to it, well, those 100 threads are gonna work on it. The same is gonna be with the cache thread pool. So it's still the concept here. You're not going to improve your performance really with higher number of articles with cache thread pools because you're still at the end going to have 100 threads.
But virtual threads are consuming more memory.
Yes.
While achieving faster.
Exactly. Yes. They consume really too much memory so that it's not, because it's still extremely lightweight, right? It's just one object in Java heap memory and how many objects you create in your application. It's going to be noticeable when you create, 100,000 of them, 1,000,000 of them, then it's going to be noticeable. But in this case scenario, for example, we created maybe 10,000 of them. In those 5 minutes, we created maybe 100,000 of them. It's a very low memory, footprint. So for example, and garbage collector always works too, right? So when you create those threads, at some point they get deleted after they're done. So still, in this case scenario, virtual threads are really excelling because they get deleted too at some point. But your threads, those 100 threads, firstly, they're very slow, and they get blocked, and on top of that, they take up more memory too. So virtual threads, they use memory more efficiently. Did I answer your question? Thank you. Any more questions? Well then, thank you everyone. And I think it's a time for a break, right? Oh, okay, okay. Okay.
Нету? Как это нету? Давай. Не замерзли вроде? Не-не-не. Свою сейчас. Да, конечно. Просто вот это. Ай, блин. Сейчас. Сейчас. Okay, so let's start our next topic, transactions in Spring Framework. I am Suat Aliyev Jahangir. I am Senior Software Engineer at Palm Systems. And today we will discuss about the transactions in Spring Framework and transactions itself. So let's start. Today's contents: introduction to the transactions and ACID principles, and transactions in Spring Framework, ACID principles, and Spring transactions alignment, and pros and the cons of the transactions in Spring Framework, and the QA session. So let's start. So who can tell me what is a transaction in DB world? Any ideas? Okay, to sum up, it is a set of commands to the database. Yeah. Okay. So this is the transaction in DB world. It has some principles like ACID. So this is the ACID principles: atomicity, consistency, isolation, and durability. So atomicity is the principle that that is for abortability. So either all commands will be executed, either none of them. So this is atomicity. Consistency is like a database consistency that will, for example, when your database in the consistent state that gets all the rules that how can I say, does not break all the rules that you put to your tables, and after the transaction is committed, these rules will not be broken. Otherwise, it will be aborted, and the atomicity will work here. Isolation is a transaction concurrency and isolation itself in the DB world, and the durability is to save your data in the durable world. For example, you cannot save your application data in the random access memory, as your computer will shut down, your data will be lost. So this is a durability. You can get further information about the ACID principles from my Medium page. So yeah. Okay, so next slide. Have you captured it? Yeah, thank you. So transactions in Spring Framework. So Spring provides a transaction support. So from 2005, and it has an alternative that was provided in 2013 by Java EE. So it has two. We can have two options. First, Spring transaction support and the JavaX persistence transactional support. So how can we use them? In the Spring, we can just use the transactional annotation in our service class or in our method. So this is transactional support. So it's very easy to use. You can lean on this how can I say, on this support, and yeah, your transaction, your application will be on the safe hands as you are using the Spring framework. So what is the difference between Spring's transactional support and the Java EE transactional support? So Spring's transactional support more customizable and more flexible. Yeah. And now we will talk a bit about the ACID principles and Spring transaction alignment. So alignment for Spring transactions, we know ACID principles are 4, and 2 of them are supported in aligned with the Spring transactions, and 2 of them cannot be, as no logic to have this one, because durability is durability and consistency is the pure database principles. Not it cannot be achieved by the programmatic way from the Spring. Yeah, and for the isolation levels, we have the isolation dot, and you can choose your isolation level. For example, read uncommitted, read committed, or something like that. And we have rollback and no rollback options also. So rollback options is, for example, you have created a custom exception that will get from the database, and you can do rollback of the transaction if you have this exception, or you can choose for which exception you will not roll back your application. So this is also can happen, these options. And propagation options is also very good options, I would say, because it will provide you flexibility and choose the scenarios of the transactions. For example, you need to create a new transaction for certain piece of code. So you are calling this piece of code from the transactional method. So this method is being executed inside one transaction and tries to execute this piece of code in the same transaction, but you don't need it. So in this case, you can use the requires new propagation option, so on. So we have several propagation options on this. So you can read further in the internet. There are a lot of resources on that. So I will not take your time, and yeah. So let's talk about then pros and cons. So pros and cons. Yeah, it is simple. Yeah, pros. Simple. It's very simple. You can use just one line of the code, and you are achieve the transactional support. It is consistent with ACID principles. 2 of them we had a talk about it, and flexibility. You can achieve flexibility using the transactional, as I mentioned, the propagation or rollback, no rollback options. Yeah, and integration. Yeah, integration is also very how can I say, very important thing, as when you use something, it cannot be it can be not supported from your framework, and this is very, very bad thing. When you try to run application, you cannot run as it does not support. You need to search for another options. So automatic rollback, we had a discussion, propagation and isolation, as I mentioned before, and customizability. Yeah, you can use, for example, your own exceptions, your own, how can I say, things. You can customize it as Spring is open source, and you can, for example, extend and give your solution to this. Okay, no, as Elior mentioned, there is no silver bullet. Yeah, and this transactional support also has its cons. For example, complexity. So as I mentioned, you can customize, but it's very complex to customize it. And performance, yeah, you can have some performance issues as frameworks gives you the standard universal options. That's why you can have some issues with the performance. And yeah, as declarative limitations, declarative transactions, yeah, might not cover all scenarios, yeah, and you can have your own scenario for the database optimizations, for example. Debugging challenges is also here, as it is the framework thing. You can have some problems with debugging. Yeah, you are heavily depend on the framework. I need to mention here one point. So my friends which works in the fintech in UK is telling me that the Europe is changed its regulations regarding the frameworks. So if you are using the library, third-party library in your application, you will be responsible for the bugs in the library, not the owner of this library. So this is very important. That's why if you have some how can I say offers from the fintech from the Europe, they are asking about the pure Java, not heavily depending on the frameworks. Yeah, I had such kind of situation. So propagation complexity, it's very hard to understand propagation scenarios. Yeah, it's a lot of options. Yeah, it can cover almost all the scenarios, but you need to be careful to choose the propagation options and database support limitations. Yeah, for example, PostgreSQL does not support read uncommitted and snapshot read. Yeah, it has options. Yeah, you can use this option, but it will refer to another. For example, these two options will refer to the read committed. So this is also one point. So database support. And that was the pros and cons. And if you have questions, yeah, I'm open for them. Nested.
Not well constructed transactional and didn't in mind the construction algorithm where to put when it's necessary when A occurs
Yeah.
in your head.
Yeah. For example, you are trying to create an order system. Yeah. In the real world. Yeah. So inside the transaction, it should be, for example, you should order something and it will try to deduct amount from your wallet, and it will update the for example inventory and creates as notification and so on. Yeah. And in this scenario, the deducting amount should be inside not inside this transaction. Yeah, it should be in new transaction, for example. Or in some scenarios that it will be, for example, like that. You should join your piece of code, your method, to the existing transaction. We can also have such kind of situations. So that's the cases in the real world scenarios. For example, you should not, for example, in the payment systems, yeah, a P2P payment systems, you should first deduct from the person who is sending, and you should add amount to the person who is receiving, yeah? And this is one transaction. It should be inside the one transaction, and if it is not, then you will have some inconsistency in the database and your database and the real world. So yeah, it should, depending on the situation and the experience, of course. Without experience, you cannot tell what should use in which situation. Yep. Thank you for your question. Yeah.
Imagining that inside one method we are requesting another microservice B, like,
Okay.
and it's a read operation.
Mm-hmm.
We are sending data, and then we like process the response from
Yeah.
microservice B.
Okay.
If something like, if exception is thrown while processing the response, can you also like roll back the read operation, so microservice B?
Mm-hmm. Okay. So it depends on the situation. For example, you are reading the data that should be processed in your transaction. Yeah. For first thing here, that what is the communication between microservice A and B? It's asynchronous or synchronous? Yeah, synchronous. Then your data that will be processed on the B is required in the process in the A. Yeah. Yeah. This is dependent each other. So yeah, you need to roll back this transaction because you need this data, and it is failing. Either you can retry, depending on depending on the how it called request response code. Yeah, you can retry, or you can, for example, just kill the rollback the transaction, as it cannot be done. For example, if you are sending a notification, it's not depending on the transaction, because yeah, sending notification fails, it will not give so much impact to the deduction of money and sending the money. Yeah, but if it fails when you are trying to calculate the percentage that you will have from this transaction, this is not a good. You should roll back the transaction. It depends on the situation always. Yeah, thank you. Any questions? Yeah, sure.
Sometimes I have seen transactional annotation from read methods.
Okay.
Only reading operation.
Mm-hmm.
Does it make sense?
Yeah, of course. Yeah, of course. Good question. So, for example, imagine you are reading the email count and emails itself. So in first transaction, you have read the email count, and in the second transaction, you are reading all the emails. Imagine, yeah. And when you read the email count, it's 21, for example. And when you're trying to read the second, another transaction came and created a new email. And you are reading 22 emails. That is the inconsistency. Yeah. You're welcome. Any other questions? 3, 2, 1. Okay, thank you for your attention. So it's time for coffee break. So there will be some pizza there. Please go there, and we can continue our discussion in more informal situations. Yeah, thank you. Wait, sorry. So.
Hi everyone, just to mention, after break we also have a session with microservices, and also we'll have some more stories of our people here, and we'll have a quiz and so please be here and join us in the second part. Thank you.
Два. Зачем мы используем только один?
А, угу. Ноутбук. Ноутбук у кого был, чтобы презентацию поставить? Значит, в принципе, можешь вот так поставить. Я вот здесь стою. Не там, а буду здесь стоять. Да. Ага. Вот так буду переключать. Угу. В самом верху вроде. Вот этот. Угу.
Не, сейчас давай, еще экран, когда вы.
You're going to start shortly, so please stay tuned. А не включен? Угу. Раз. О, работает. У нас так. Угу. So without a presentation, I guess we may start. Like I can start by the introduction part. So today we're going to talk about a introduction to the asynchronous messaging in the microservices. So let me briefly talk about myself. So my name is Javo here. As my name suggests, I'm a Java developer here at EPAM. So I was born like destined to be a Java developer since my beginning. So yeah, that's kind of destiny. So, and here's my brief introduction. Like I have a 4+ years of experience in overall software development in a commercial industry. So although I look a bit old, but I'm a young. So by looking at my experience, you may see that. And also besides it, I was a mentor at the ITPU University. So then I decided to stop teaching and focus only on the software development side. So enough of me. And today's agenda here, we can see that we have an overview of the microservice. So firstly, we're going to talk about it. So some kind of the main difference between the microservice and the monolithical applications. And then we're going to talk briefly about the synchronous and asynchronous communications. What are the differences between them? And the third part, we're going to talk briefly about why actually we need the asynchronous messaging at all. And then later we're going to talk about the pros and cons, and then we conclude the presentation and with some QA sessions. So let's see here. So we can see that the monolithical and microservice. So in fact, the monolithical application is the kind of application which contains all the business logic inside of a one application. So it's like a one house, like one room even, which has a kitchen, bathroom, living room, dining room all together. So basically, monolithical application is all we need. If we don't have any users at all, if the number of users are small enough, so because it is fast to deploy, it's easier to develop, and so it's much easier to do because, but with the microservices, everything is decomposed into the multiple parts. So they are independent. So it's like having a separate rooms for each purpose. So it's like dividing the business logic by the components. Yeah, for example, you might have a logic of, let's imagine that we have some delivery application, yeah, like Uzum Market, we might say. So we might have an order service logic related to the ordering, delivery, shipping, and payment service. Yeah, if it's like monolithical, it will be all of them will be combined inside of one application. If it's like microservice, they'll be split across the multiple services which communicate between them through the synchronous via REST API, we might call, or asynchronous via message brokers or some kind of queues. So in fact, if we have a lot of users, so we need to make it more scalable, yeah, because if there is a single room, we try to put a lot of people inside of it, so we might have no room available at all. So that's why we need to make them separate as more as possible, corresponding to the increasing amount of users. So that's why we need the scalability. So the point of the microservice is having a high scalability of the application. So, but if we don't have users at all, so monolithical application is the best one, because some of the companies even don't, without having users at all or small amount of users, they actually focus on creating the microservice application. But it doesn't make sense if we don't have a lot of users. So microservice is only for the high number of users for the scalability purposes. So in fact, each service should have its own database, yeah. But if it wouldn't have its own database, so it would be considered as a distributed monolithical application, yeah, because it might look like a bit like a independent, but in fact, all of them go through the same door, yeah. All of them access to the same database, the same resource. So somehow it doesn't make sense, yeah, to call it microservice, because at the end, there will be anyway the single point of failure of the database. If the database will not work, so the whole application will go down. But we're gonna achieve the modularity, so it might call like a modular application, yeah, split across the different modules. So, and yeah, let's talk about asynchronous messaging. So in fact, let me give you I know most of you guys have already like experiences about microservices, about asynchronous messaging, but let me explain it a bit in a playful manner. So like kind of imagine the kitchen, yeah? So the kitchen, you all are the clients. So let's imagine that this room is a kitchen, yeah? So I'm gonna be your waiter. So I'm gonna like get the request from you, yeah? You're gonna tell me something, yeah? You're gonna order some food, for example, plov, yeah? For example, black tea, and I'm gonna wait for you, and then I'm gonna go back to my kitchen. So then I'm gonna wait here until your food is prepared. And then I'm gonna go back and receive it to you and give it to you. And I'm gonna go to the next client and I'm gonna get the request from her. And then the process will continue until I'm gonna finish with the last client. If this is the case for the single threaded application, yeah, if there will be only one thread, so I'm being a one thread here. I'm being a one API thread of one API. So it's called as you see, this is a synchronous communication. It's happening asynchronously because I'm waiting. I'm waiting till I finish my one task. Yeah, and also I'm gonna being like a request and response. So I'm gonna getting request from you, and I'm gonna waiting for the process. I'm gonna processing it, and then I'm gonna going back. But instead, if there will be like more like me, the person waiters, of course we're gonna be like, but still we will be waiting until we finish with one person, yeah. But what would be if it's like how we can increase the process, yeah? Instead, I could get a one request from him, like hand over to the kitchen and go for the next client and get the request from another one. I'm gonna continue. So I'm not waiting for the one process to finish. So it's happening asynchronously, yeah? So that's the point of having the asynchronous messaging. Again, it's all about the scalability. If I have a lot of clients here, so it makes sense to have asynchronous. If I don't have like, if it's like a small amount of clients, so it doesn't make sense. But the difference would be not that big. So it is like for the sake of saving some time. So that's why we need a asynchronous messaging. But yeah, this happens with the REST API. So request response approach, it happens with the REST API. So REST API is like a abbreviation of the representation of the state. So it's called the network, the communication through the HTTP calls. So this is how it happens, yeah. And also to improve that process, we might introduce some intermediary operation, some intermediary broker, which would decouple all of these tangled communications, yeah? So instead, all of them would not communicate to from one to another, yeah? They would go put their requests into the broker, and the broker would handle all of the requests asynchronously. So the one service itself would go without waiting for the response to come back from another service. So this is how it happens. Yeah, we can get a scalability, resilience, decoupling, and better resource utilizations by doing that, because waiting for the resource to happen, because we are spending the memory, we are spending CPU operation time, yeah, by waiting for the response to come back to the client. So that's the case with asynchronous messaging. The next slide. So I got the nice picture from the Byte Go. I would suggest you to read some articles from this site, because they actually make a weekly newsletters about the system design, about everything related to the software development, yeah, on a higher scale. So we talked about the request response approach, as I talked before. So we can actually get it over the HTTP, yeah. So when the request comes to the service and receives synchronously, yeah, like instantly it's called, yeah. So we have four types of the communication patterns, yeah. The first one is like shared data file, yeah. So we have a couple of services, but have one shared file. So it can be like a shared source, kind of shared source. But the cons of using this approach, that we might have a race conditions and data race situation, yeah, when a lot of threads, a lot of operations. So thread is actually one worker which does the one job, yeah. Job, we might call it as operation. It can be like, as Jahangir said, the transaction, yeah, which is a set of operation, or kind of transaction which contains only one operation. So we might call it, so the thread works on that, yeah, does the one transaction, does the one job. So by doing that, because we also need to care about a locking mechanisms here, because a lot of communication is going on, because the shared resources is used and updated by the various sources. So it is like not that kind of best practice, but it also has its own use cases as well. And the second one is like event-driven with a message broker, the typical example of the event-driven architecture. So we have a concept of topic, yeah. So in Kafka we have a topics. So the topic is like a combination, it's like collection of events, yeah. So we might have a different topics. So the topics collects that kind of particular event, and then a consumer can get any kind of message, yeah, what they need from that topic. And the topics are divided among the partitions. So partition is like a chunk of topic, yeah? And that partitions can be split across the multiple nodes. A node, in fact, is like just a server, or like just one computer which is located in different region, yeah? So we might call it so. And it gives us possibility of having a distributed application, distributed message broker. So the architecture is Kafka is like that. So it has a distributed nature, and that gives us that edge, that it makes it fault tolerant. So that means like if the one node goes down, because of the electricity or because of some natural disasters, so other computers can pick up and continue working, continue operating. So that's how we will achieve the fault tolerance, resiliency, and we might avoid having a data loss, because data loss is really bad situation. We should not have it, yeah, or like data inaccessibility and something like that. And also by using the queues. So this is we have in fact two types of the message brokers, yeah. So like for the event sources and like a queues, yeah. And the queue example of the queues can be a RabbitMQ and like a message ActiveMQ, ArtemisMQ, and so on. So in fact, we have a request response based, but it is asynchronous, yeah? So producer puts event to the queue, and then consumer consumes it from the queue, and then puts its response to the queue. So this happens like completely asynchronously, yeah? So no one waits for anything, yeah, from anybody. So that's the point. So we already talked about request response approach. So let's go to the next slide. And then let's talk about the challenges we might have using the asynchronous messaging, yeah? The first problem is, so this is like a typical kind of simple example of how the message broker might look like, yeah? We have a senders, we might call it as a producers, senders, yeah? And we have a receiver, which can be a receiver or like a consumer and other. And also we can have the sender can be a one application. So the sender this can be the instance, yeah, the clones of the same application to have a high scalability. And also here we can have a consumer, the one consumer or like a different services as a consumers or like a one consumer, different instances. So we can combine them as a group called a consumer group, yeah, in order to avoid having a duplicate messages. So the first problem is like eventual consistency, yeah? So services may not see the data, like updated data at all. So for example, because we're having a distributed services, distributed system, it have its own instances, yeah, like copies of the instances, and it happens through the network, yeah? For example, but it's called eventual because at the end, the data might be updated or might not be updated, yeah? But anyway, so for example, like when something happens, yeah, like through the message broker, like through any kind of communication, yeah? So somebody requested water from me, yeah? So I'm gonna picking up the water from the service, and when I was going back to the client, yeah, to somebody who actually ordered the water, but somebody killed me, yeah, and the process is failed. So I need to be or I was exhausted and I fall down, yeah. So I need time to get some power and get up, yeah, on myself. And then what I'm gonna do? I just forgot to give water for the person who actually ordered the water, yeah. And then what I'm gonna do? I'm gonna pick up the water and I'm gonna give the water, and like by doing that, so anyway, the water will be received, yeah. So we're having eventual consistencies, like, or somebody ordered a water, like ordered me a water to hand over the water to somebody else, yeah. So I'm gonna do that, but anyway, it happens after the recovering the power. So we have a eventual consistency here, and this is the case of the message duplication as well, because the process is stopped. So we might assume that the network is reliable, but in fact, in the real world, the network is not reliable at all. So because of that, because there is a high latency among the service. For example, if you might imagine that going to this place, it's much faster for me than going to that place, yeah? So it happens that it takes some time for me to go to that kind of places because it might something happen during this period. So this is the case with the network as well. But even though the network speed is like close to the light speed, but anyway, there will be a difference between the latency because the geographic regions, like some places might be close to our services where it's located, yeah. So having a geographical proximity, it actually makes the request to be finished much faster. So that was the message duplication case, yeah. So in case of that failure and the recovery, so message broker might assume that it has not produce it, like gave the message, and it's supposed that, but it mostly happens with the producers. Yeah, producer might forgot that it has put the message into the queue, and then it reputes, like resends that event to the message. So that's the case with the message duplication. So we have to handle that duplication on the consumer side. So by doing, we can actually talk about in the next slide as well. And also the problem with the complex error handling, yeah, because in fact we have a lot of services, and a lot of services has a lot of place to work. So a lot of works actually creates a bit complexity of doing that. So, and retries, yeah, as I said you before. So in fact, the sending the message itself has different types of sending the message, like by the message brokers. We might say at least once delivery, exactly once delivery, and exactly once processing. So at least once delivery means that message needs to be sent exactly, like more than one time, may send more than one time to the consumer. So that's the case when we need to have a, like was the case of the handling the retries, yeah, because of something might happen and our message might not be received by the consumer. So that's the case with a retrying. And also we need to put sometimes some systems might require the message ordering, and yeah, and also idempotency. Idempotency also might be related to the message duplication as well. So yeah, and then overall the system complexity will be increased, like by using these kind of tools, because asynchronous nature is also difficult because it's not a straightforward. So it's not like debug and everything will be clear, because it will be the nature of the asynchronous, like you have to wait something, yeah, because it's not going to wait for the result to come back. So it's always like working with the futures and promises, yeah, but the promises may not be may not be done. So that's why. And yeah, and what about the best practices here? We talked about idempotency. So like we need to ensure that the message was not processed multiple times by the consumer. Yeah, for example, if you make a payment, yeah, it has to be processed exactly once. So it should not be like, even if there will be some network delay on the systems, it has to be exactly once processed, yeah. Otherwise, you will be charged twice. So that's really bad. So that's why we have to make sure the system is idempotent. How we can achieve that? It's just simple. On the producer side, we just need to generate the ID for the event, and we need to put that ID to the event, and then when we send it, so the consumer first checks that ID of the event and sees that whether or not it has already received that kind of message. If it's not received, it's gonna save it, and then it's gonna get some like a journal and puts it that I'm receiving the event with this kind of ID, yeah. And the second time that request takes place, and then consumer sees that it's already received that message, and it just ignores the message at all. So that's the case with idempotency. And the retry mechanism, so like because of that, yeah, connection delays or connection issues, you might have that situation when the message is not received at all. So that's why we need the retrying the mechanism. Yes. So here is the example of the retries. So we might use a dead letter queue, yeah, because like if the message will not be processed by somehow, yeah, because of the network, some delay, yeah, between the broker and the consumer, we can put the message into the dead letter queue, yeah. If, for example, we tried 3 times, usually it takes 3 times before putting the message into the dead letter queue. And then we can, like, when the system will be available, when the consumer will be available, we're going to get the message from the dead letter queue and try to resend it again. So, and the retrying the mechanism also, it's called the technique is called a exponential backoff. So that means like the time for sending the message is like will be increased exponentially. Yeah, for example, between the first and second retry, it might be first time 2 seconds, and the second time like 4 seconds, and then 16 seconds, and etc. Yeah, so it can be chosen. And also what are the best? So these are the best practices to have, yeah, idempotency, retry mechanism, and DLQ. And also, of course, we need to have some monitoring and tracing tools, yeah, because that makes it difficult without having proper monitoring or tracing tools to troubleshoot the problem that might occur during our development. So as a monitoring tools, we can use for example, Prometheus, yeah, or like a Grafana for the visualization. If it's like a AWS, yeah, cloud infrastructure, we might use a CloudWatch and etc. for tracing like any kind of cloud vendors. They have its own like tool called it like for example for the AWS it has called X-ray, yeah, to trace the event itself, so how it goes. So yeah, so it will make our life much easier to troubleshoot and to debug the problem. So I guess that was the last slide. So if you have any questions, please feel free to ask. Mm-hmm.
How do you handle transactions in this medium system?
Mm-hmm.
Nowadays, like I see that you can have asset transactions.
Mm-hmm.
But what about this microservices? Can we have these asset transactions
Mm-hmm.
or another techniques?
Yeah, this is a nice question. In fact, transaction can be as Jahangir already mentioned, it's like set of operation, yeah? Operation it's like the interaction with the database. So it can be any kind of CUD operation, yeah? Creating or reading or updating or deleting. So it can be the combination, all of them. So we call them the combination of these operations as a transaction. So it can be big enough. So in the microservice, in fact, if the transaction is really big, it takes really big, more time to process it. So because of the nature of that, because we need to work on that different services, yeah, or like many different services may be involved in it. So if the process is taking too much time, yeah, we can actually make it asynchronous, yeah, because we don't have to wait. We just put that transaction, yeah, on the one side and do our own job, yeah. So this happens like asynchronously, or we can actually split the transaction into the small chunks. It's called sagas, yeah. We have in the microservice we have pattern called sagas pattern, yeah. You might actually read about it on your own. So in fact, yeah, like sagas, like it's in fact it's called a saga because like saga is like a continuous, like continuing the one part, yeah. So like having the multiple parts. So that splitting the transaction into the little chunks is called a saga. So and it will be like handled in two ways. We have one service will act as a orchestrator, and one is like choreograph, kind of like that. So we have two approaches of handling that kind of scenarios when we have a lot of transactions or like a big transaction when we need to split it. So like in orchestrator, one service will be responsible for handling that transaction, yeah, for handling that big transaction. It's going to say that, so, okay, you divided this and I'm going to put it like, so it's going to control the whole flow. Or if it's like a choreography way, it will, all the service will be like, it has to be like, all of them will have to take care on their own, like how the whole process will go, yeah, because there'll be no one entry point which will lead the whole transaction. So in fact, with orchestrator, we have a single point of failure, because if that orchestrator service will fail, so the whole transaction will be at stale, or like it will be kind of in a bad condition. So yeah. You're welcome. Any more? Yeah, please go ahead.
Let's assume we swipe out the cloud system.
Mm-hmm.
You have on-premise system.
Mm-hmm.
Does it make sense to use FN service system without
Mm-hmm. Yeah, if it's the case with as I understand, like monolithical applications, yeah, on premises, like.
Can be on-premise.
Mm-hmm.
Not have access to
Mm-hmm.
system.
Mm-hmm. Yeah, but like if it's like on premises, that means like we don't use someone else's computer. We just put all those resources inside of our data center. Yeah, 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 of course, because it does not affect our Kafka, but the problem is of using the on-premises data centers, yeah, if it will be all of them located inside of one region, yeah. So if something might happen on that region, yeah, it will affect the whole application itself. So because if for example, electricity will shut down on that region, so it will affect the application because there will be only one data center for that kind of, but it doesn't like related to the Kafka.
Implementation of such a system without orchestration or
Yeah, like orchestration is like for the Kubernetes, it's like when we have a lot of containers, yeah, like it's only used for that kind of purposes, but it depends, yeah. If we have a lot of, but anyway, on premises systems, we might still use that orchestration tools, but again, it is related to the scalability purposes. If we have a lot of users, we need to have a faster access, yeah. If we have a one application at all, one instance, yeah, all user will go to that system, yeah, and then it won't be available to handle more. We need to like scale, so create a more pods of it, yeah, or like containers of it, like instance of it to handle more requests, yeah. We need to just clone it. So it doesn't relate it with a on-premises or not nature, but all of them will be located inside of one region. So we still can create that, or use the orchestration tools to do that.
what was the realization of actually it was about a month.
Mm-hmm.
You probably use AWS cloud system.
But it depends, yeah. It depends on the, yeah. It depends on the which project it is, yeah. For example, some project might require to use a AWS. Some of them may require the Azure, Microsoft, or some of them like GCP or any other like cloud vendors, because the cloud infrastructure is like an abstraction and implementation of it's on the side of the client side. So it can be only like a on-premises at all, but mostly devs, developers, some of them might have the access to that kind of resources, some of them not. So it's mostly like closer to the DevOps side as well. Yeah. Welcome. Any more questions? So if no questions, thank you guys for coming. And yeah, that's all from my side. Thank you so much. Thank you. Cool. So.
So now we want to invite our successor and first student who has completed our courses. Asledin, welcome. Could you please take it here?
Thank you.
So we have asked Asledin to share his success story with us, with you guys, and you will be able to ask any question you want at the end of his story. So, Asledin, thank you.
Thank you. Well, hello everyone. Well, I'm Asledin, currently working as a junior software engineer at EPAM. So, well, I'm really proud to say that I'm one of the graduate students of MJC School. And well, to be honest, unlike Jawahar Ake, like my story began, I started my career as a musician. I used to work in orchestra, like I played one of musical instrument. Do you know, guys, what orchestra is like? Yeah, group of 60, 70 people together play some music. So in about 2022, like I decided to quit my job and to learn about to be a software engineer, to learn about IT and this kind of stuff. And I tried to study different courses from Udemy and others. And then I fortunately, like I have like how to find this MJC program. Like one of our teacher like recommended us, and yeah, it was really great. The materials are great, and one of the most thing that I like is the course is practice oriented, and you will learn something and you apply it, and tasks automatically like tested with the help of AfterCode. Yeah, it's great, and you see your results, and yeah. Yeah, I think that's it. And thank you for all of the like mentors of like MJC program. And yeah, I'm really grateful. Thank you for all of you.
What was the challenges you encountered?
Yeah. Good question. Well, as I said, I was a musician and I had no background in like IT. And yeah, in the first modules, like it has a 5 module, I really struggled and I didn't know what is going on. Like the materials were hard for me. And fortunately, we had a mentors like chat. We asked, and some of them like devoted their time to have a call and to fix our issues. Yeah. Mostly I asked supports. Yeah, it was like this.
Do you have a math background?
Well, to be honest, in school, I studied like not like best. Like I was not the best. Like, but I know like in general, but not so much.
Fine. What's the most thing you dislike it in the MGC? What's the disadvantages or the problems you encounter?
You know, it's really difficult question. It's yeah. It's yeah.
We're gonna fix it.
Yeah, yeah.
Next question.
I mean, yeah.
So I can recommend my friends about the MBC school, pros and cons, and I can say
Sure.
you can try without math background now, and I have a cons and pros, so I need more detail about.
Sure. I definitely encourage you to like say your brothers to study this program. Well, regarding your question, like I think I cannot answer because you know everything I learned like from my main stake is Java, and I learned from this program. You know, it helped me a lot. Like I cannot say like everything was perfect in my opinion, and yeah.
Can you give some advices or feedback about the course for the authors? Maybe you're the authors of the Java course.
Well, there are a lot of contributors. I think it's like not in Uzbekistan. Like there are a lot of places they like conduct these courses, and the program is one. Like it's developed from, if I'm not mistaken, EPAM engineers, and yeah, and the material is mostly text-based. It would be like you will read a lot of things. There will be links for the documentation and all other stuff, maybe books and presentations. Yeah, it's mostly text-based. And as I said, you learn something and apply this. Like it's a practice-oriented course.
How many hours per day do you spend on your learning material?
Well, on average, it was 3-4 hours. Like, but some days I had like 6-7 hours, and some days 2 hours. But on average, it's like 4, I guess.
Was it difficult to combine your learning and other stuff like working?
Well, yes. At the same time, I worked as a like teacher for the computers literacy. You know, yeah. At the time, I have a knowledge about like Google Docs, Scratch, and something other simple technologies. And yeah, at the same time, I worked, and you know, it was tough. Yeah, nothing comes easy. Like you have to accept this and you start doing and try to achieve something. Yeah.
What was your main motivation to learn?
Well, the the biggest motivation I had, yeah, we are, for my parents to be proud of me, and therefore I quitted my first job and tried to make something useful for everyone, like every community members take advantage of something that I built. Yeah, this is my motivation I have, and I had, and now I have. Like it is the same.
The last question. I believe that you had such kind of moments when you want just to give up everything because learning procedure is not easy, yeah, for everyone, and of course we should combine our everyday life with it. And in this situation, how did you help yourself? So maybe you have some advice for
Yeah.
future students.
Well, I want to give one quote. Like I think it will help to understand. Like everyone watched Rocky film. I think, yeah. In one of the movie, he says that one more round that you think you can't change everything. Like if it's really tough, and you should like wait a little bit, and the interesting things comes after this. Like, yeah.
Thank you.
How long did it take the whole from 0 to 4?
Well, each stage usually takes from 2 to 3 months, depending on how much you spend. Yeah.
Actually, I'm on the first stage, and then nobody left. Actually, the guy was based in Turkey, and then he left the MJC school, I guess, right? Maxi.
I don't know.
I mean, we open now in Uzbekistan, so things like that are not gonna happen.
Okay.
You do not have information
Okay,
about that.
then,
locations.
How many months did it take to be a software engineer at EPAM from zero
Well,
for you?
I think it's near 2 years. Yeah.
You have started the MJC school 2 years ago. Right.
No, I started about in 2022, and after completing, I had a chance to have an internship at EPAM system. Like it's like a more. We had a practice. We had a like one-to-one mentorship, and also other materials to read. And also it took me about a year. And so in August, I received my position, junior position. Yeah.
How long did it take you to the whole course from 0 to 4?
It's only about
MGC?
Finishing the
Yeah,
finishing the
I think about year or so. Yeah, I really encourage who wanna learn about Java and its libraries and other cool technologies, like advanced technologies, like we have in the last model AWS. And yeah,
What the Java version?
at that time,
17.
17 in the MJC school.
yeah, your code, like your task will be tested automatically, and there will be pre-written like unit tests. And yeah, mostly it's I think 17, but I cannot properly remember this. It's near like it's I think above 8 for sure. Yeah.
I want to know if they have added some new some topics in the newer versions. For example, the features in the 21st version or 17th version, or just 8th version, and you will join EPAM. You learn the oldest LTS version, and you have joined EPAM, or you learn some newer versions of Java.
In interviews, like they will ask from juniors, at least they will ask mostly how you understand Java ecosystem. Like there are something that will not change often, like the core. And yeah, also in terms of like Spring, for example, you should know, for example, Spring Boot. Like they will ask some question about it. Like in the course specifically, it's like mostly the fundamentals. Like you will learn, you will gain the knowledge of like how these things is going on. For example, you know, you have you used Spring, like Spring Boot, let's say, everything like is auto configured and you write your business logic. But in this course, you will start from the first steps. Like you will learn like how to use GDBC, like, you know, Hibernate use GDBC. And then you will go one up, like you will learn Hibernate. Then you will write everything with classic Spring without Spring Boot. Yeah, it's like, you know, it's you will gain the understanding of how things work under the hood, like not from the above. Yeah, it's a bottom-up approach, I would say. Yeah, thank you for all of you. Yeah, thanks. Okay.
Oh,
Sorry.
So let's spend next 5 minutes for the opportunity to ask any questions to one of our main MJC driver, Alina. And of course, she's going to tell you about her own success stories, about her beginning in MJC School.
Hi everyone, I hope you remember me. My name is Polina and I'm head of the MJC School, so I want to share with you my story. When Elior did his part of presentation in the beginning, he mentioned that you also can stay in the community when you graduated from the school, or if now you feel that Java is similar to you, everything is clear and you don't really need to be part of the school, but you feel that you want to contribute. So it is possible for you. And let me share my story, how I joined MJC community and how I became the head of it right now. So it was like for me probably 4 or 5 years ago. It was the time when I actively participated in our EPAM mentoring programs. I was a mentor in several programs. I was run coordinator when I actually was responsible for all mentors and for all stages. And also I sorted out some technical and organization questions. And also I've got the chance to contribute to mentoring programs. So I took some topic and like our speakers today prepared some materials, like dive into the details, and then were able to create the presentations or some materials for students who doesn't have the same understanding, but we can kind of explain in simple words. And I felt in this way that I really like it. I really like to take a topic, learn about it, learn some details, debug the code, debug like Spring framework or any other framework, just to understand how exactly it works and why I see what I see when I run my program. So the programming for me is not a magic. When I run the button and I see error or I see some success results of the code, I always know why it is, because it is written in the way how it works. And for everyone who feels that you have some magic in your work, it is not a magic. You just need to probably spend some more time on learning. And this is what happened to me 5 years ago. And in this time, I know that the group of people was already formed within the Java community, who were starting to think to create an open source resource that will be available for everyone, no matter how old are you, no matter whether you have technical background or math education or like anything. You can just access this free resource. Start from the beginning, learn the basic from the ground, and then the complexity of each stages, they kind of bigger and bigger. And if you don't have basics, you will not be able to be part of the later stages, because you will need all these basics to write the code and to actually feel that there is no magic in programming for you, that you know what you're doing, that you can take the task and you already know how you will structure your code. So it's all inside your head and you understand it. So this group of people who founded the MJC School, we saw each other in mentoring programs, and they also were mentors, contributors, and like we always were kind of in touch in this community. And one day they came to me asking, maybe you want to contribute to us. We have this idea and we need people who will help to build it. If you're interested, you can join. So I was interested, I joined, and I remember my first topic was exceptions. I really like exceptions because in my current work, we have lots of QAs and usually they just throw in a bug to you, like, I have error, do anything with this. And I felt that it's the wrong way to deal with bugs like this. And I, inside my project, we created a mentoring program for QAs, Java for QAs. So when they see error, they can open logs, they can read logs, and say to the developer not just error, but particular lines from this error message that also will give developers information on what happened. What exactly is it out of memory error, or is it like some business type of errors? So it speed up the time that developers spend on bugs, and also our case, they became more confident talking to developers because they started to understand more things, and this magic was ruined for them. So there is no magic for QAs in our project right now. As I was deep in this topic in my project, and I participated in MJC School and was part of a contribution team who was working, like I started from exceptions. So probably some of your tasks or explanations of this topic can be written by me. I don't remember right now. But yeah, this is how my journey started in MJC School. Then the school was launched and kind of my contribution work was finished, and I kind of take a step off the school for a while. And then we in the school started to have more formats. One of the format is roasting, and second is light talks. You can find them in our YouTube channel. We have recordings in our videos, so you can find how they were conducted and what exactly we mean when we say roasting or light talks. So just the overview, roasting was the type of sessions when we have the students who decided that they want a mentor to ask them question about the topic, so they are confident in this topic. And we had like a forum where our mentees were signed off, and then a mentor took the session, asked the question about the topic, and mentees were answering the questions. Second type of the events was light talks, is when we have, for example, one small topic, Java collections, for example, and we are doing a light talk. So it's additional kind of tutorial that recorded on video with some details, with some examples how code is running. And this is all done by people who working in daily basis with this. So it can make some things more clear. And in slide talks, we also had this room for questions, like we did it today, for example, when if you see the topic, you think that something is unclear, you can ask, and it was recorded also. So please scan our YouTube channel and join to see how it works. And in that time, when these two sessions were present in MJC School, we started a new region. It was Lithuania. And I was invited to be part of the mentors who were conducting kind of lecture sessions for mentees that was in this region. Because we just started, we were unsure what is the level of our mentees, and we wanted to kind of explore the region as well. And in that time, it was a good format. So we had a group of people who conducted sessions regarding some topics, and then mentees were participating in the like general journey in MJC school. And after this, I like second time take off from the school, and I didn't hear about it for a while. And this year, like head of the MJC school that was before me, Oleg, he found me at IPAM and asked if I'm interested to be now the head of the MJC school. And we had a talk with him regarding what is the plans, what is current state of the school, and what they had in the plans for the school for future, and how in general we see the future of it in different regions. And he mentioned to me that we have Uzbekistan as a new region. I was surprised because when I was here in the last time, I mean in MJC school, we just had Lithuania, and we didn't think about other regions from what I remember. And now we kind of grew a lot. We have several locations. We have multicultural environment, and also our mentors are from different locations, and our students from different locations. And yeah, we had a talk with Oleg, and I decided that it's a fun for me. So MJC School, if you want to be contributor, I encourage you to find the area where you kind of can have fun for yourself, because we all understand that it's a workload additional to your project, to your work, and it should not be a burden for you. It should be something that you have as a like source of inspiration. And that's my journey in MJC School as a contributor from the beginning to the end. And who knows, maybe in future we will have someone else as the head of the MJC School. Maybe I will, decide that I did everything that I wanted and I will go away again. Yeah, so that's my story. Our questions.
Actually, I have again questions. The mentorship program. Actually, we have Discord channel, etc. And there were many questions, but nobody partly answered. Especially the third, fourth stages, and then like we probably left the questions not asking from Discord server, but people around.
Yeah, that's a good question, and that's a good feedback actually of the current state of the school. And like we were joking a little bit several minutes ago that we are not welcoming feedbacks, but we do welcome feedbacks, because kind of when we started, everything just was going on smoothly, yeah. But when time passed, we know that there are some areas that require improvement, and we want to know them. And I also noticed this situation when I joined again MJC School. I noticed that our Discord channel is not that active that it can be. And we have various of, I think, combination of factors that happened. So the Discord chat became like this. First of all, we were not always in Discord. We had Slack, and Slack community also was quite big. But then we decided to move from Slack to Discord, and kind of a little bit slowness happened. Because like the new tool, mentors need to learn how to use it. Notifications, it doesn't work the same way. So this became a little bit slower. And also we constantly have a group of mentors that also may be busy or even like not interested to participate anymore in the school, but for some reason they hesitate to highlight it to the run coordinator, because we have stage coordinators, especially for last two stages. And that's why kind of sometimes like, we had the impression that everything is fine, because we didn't know information. Yeah. So this is one of my plans as the head of the MJC school now, to make it more supportive, especially this question and answers block. So in future, all new people who joined, they can like receive response earlier rather than just wait or ask for your friends or anything. Yeah. Thank you for your feedback.
And one more, better, I guess. I saw from the front-end course rolling scopes, they had the regional ranking schedule. For instance, guys are seeing each other, motivation they have gained. For instance, we ended this stage, that would be motivation for guys. You can filter Tashkent and see the guys around
See the global ranking for the student, or maybe just
doesn't matter. I mean, if they see each other, maybe they're motivating each other and then I mean ranking.
Yeah, I understand what you mean. So right now we don't have it. That's true, and I think that if it will be possible, we can actually like plan it and introduce to MJC school for future. Why I'm not sure if it's possible, because I'm not sure how we can collect the ranking. I need to explore this area a little bit more, but I will add it to our improvement plans. So hopefully we will get it soon.
Actually, that was just an idea.
Yeah, that's a good idea. It's always good to share your ideas, because you can inspire us, to kind of improve our school. Because like when we work on something, we see things from our angle, and it's always good to have additional look from inside or from outside, because it can change the perspective and like inspire people to do more, or even highlight that this area is more important right now rather than others. So that's good to share the feedback. Okay, any more? Okay, let me tell you some future plans that we have for MJC School. It was a great question regarding the Java 21 features and whether we have tasks for it. Right now, we don't have it. And our plan for like the next several months is to review the program of the MJC School and add maybe some missed parts that are important now, for example, features from Java 21. So our students can gain a little bit more experience with the latest Java version. Also, the plan is to review existing like difficult tasks from later stages to make sure that they still up to date and in line with technologies that requires from Java junior developers. And if everyone wants to contribute to it, help us to review and provide the feedback. For example, even you as a mentee, like you just joined the school, if you have some friends and like you have casual talks like that, you are doing, I know, homework for arrays, and they asked you, oh, this is new feature, do you use it in your homework, and you don't know, you can like send a mail to us or ask in Discord or something that, oh, I know that it can be added to this topic, my friends shared with me, I'm not sure, but maybe you can consider it so we can improve. So it's also very welcome feedback. But if you experienced in Java and you want to help us review the program and contribute to it, you also are very welcome. You can find Elior, and he will find me, so we can work together on it. Okay. Thank you. Не нужно? Да, давай его. Так, нужно презент на эту стрелочку. Презент, ага. Конечно. I was inspired. I was inspired with my like my colleague inspired me inspired me to to answer one more question. Like, I'm in Java and in EPAM more than 10 years. How I stayed here? Like, we all know that when you start something, new job, you can be inspired by it, like have a lot of money from it, or like anything, gain new friends. But then you will have the period when you not giving up, but everything is clear for you, nothing is new, and your life is like predictable for you. All the tasks on your work is also predictable. So you can think that maybe I need to change something. Maybe I need to go to another company. Maybe I need to go to another project, or even switch language from Java to any other language like Python, or I know, Go, or like anything. Also, you can decide that you want to be front-end developer, for example. So how I stayed in Java for such a long time? And my answer is that I'm very kind of strive for the details. And in my project, each task that I received, it was like the combination of two thoughts in my head. First of all, I need to meet deadlines. Yeah, I need my code working, developers happy, QA is happy, project manager happy, everyone happy. But we all know that you can Google answers and just copy paste code, it will work, everyone is happy. But I was not happy because I know that, okay, there is a deadlines, but I don't understand how it works. I know like something, but not everything. And this kept me kind of thinking and finding time to spend a little bit more. So I finished my task, and then I kind of had like several hours just trying to understand more in details how it worked. And it happened that Java and its technologies always improving. So when I started, it was Java 6. We had Spring 3, I think, and it was really hard. Everything was easy, but it was all predictable. But then Java 8 appeared, and all these lambdas and streams, they were so new. And in our project, we also kind of, each customer actually, each customer wants to improve because they have some other like auditors who audit the language used, libraries used, and so on, and ask to upgrade. So we constantly were upgrading our project code. So we received new technologies, and each time I was in positions that I don't know anything. Like Spring Boot, what is that? Like, why? We have Tomcat, everything is clear. You have your application, put it on Tomcat, everything works. Monolith, perfect. On-prem services, amazing. You can just log into it. But now, and then we had like Spring Boot. Spring Boot changes the way how you deploy. You don't need Tomcat anymore. Like, and you're thinking, but I have Tomcat, now I have Spring Boot. How I can connect these two services together? Because Tomcat is like 60 web application on it. And my one Spring Boot application separately. Then you started to think, okay, what is microservices? How I can do these transactions? How I like achieve the same goal? How they can communicate within the network and not to be too exposed outside? And all these challenges, they always come into your work, no matter what project you're working on. It just like I want to encourage you to spend additional 10, 5, 15, how many you have minutes to just think like what in these areas that I'm doing right now is new for me, where I can spend this additional like 20 minutes to read more. Even if you spend like this less, like this much amount of time and do it constantly, then you will always have this passion for Java and for your project and for work. And also, I want to encourage you to not forget about your soft skills and about the community, because community is the key. Like when you struggle on something project, and you will have such period of times, you need to have supportive environment around you. And if you think that you can't find it, you are mistaken. We're all here together. We all had the same challenges during our like career, and you always can ask for help, for support, or just share your experience. And also, like at EPAM, for example, we have lots of soft skill trainings, but you can find it in any other resource as well, and it also will help you with your career, because we all know that we are working in society and you can't be just technical. You need to build some communication with people and learn, for example, some time management and other skills that is more soft skills. So that's answer of the questions that my colleague asked me to share with you. Thank you. Sorry.
Okay, so now we move on to our questions through Mentimeter, and our first three winners in this Mentimeter quiz will receive special prizes, branded prizes. So please go to menti.com or use our QR code. You can see even use code of this quiz on my screen and here. Yeah, the bigger one. And let's wait a little bit until others will join us. So here we have several questions from the materials that you received during our open day. It can be tech questions, it can be like questions about EPAM, MJC School. So we will check who of you were like the best listener for today. Okay, 14 people join us. Let's wait one more minute. 15. Even our e-palmers can participate here, guys. Welcome. But yeah, the event is open for everyone. So, and you will have only 10 seconds for each question. Be quick and attentive. So, are we ready? Cool. Let's move. $14 players ready, 15, 18, 19, 20. Okay, great. Let's start. So the first, oh, and where is the question? Yeah. Давай проверим, где все вопросы. Ага.
Так, ширить надо, стопнуть.
Sorry for these tech issues. Вот есть же вопрос. А, нет, это не тот. Это мой первый квиз. Зайди на Ментиметр. Нет, вот, ну, в смысле, в свой Ментиметр, не презент.
Черный текст на черном фоне.
А, все. Давай выйти из презентинга просто. Как можно выйти из презентинга? Вот здесь крестик. О. Cool. Вот здесь синь. Ага, вот это. Нет, подожди. Давай закроем и заново начнем. Окей.
Как можно ресетнуть? То есть сейчас же первый. Не знаешь?
Давай, вот так. Ой. Manage results. Reset results here.
Все знают.
Okay, it was like a test. Okay, so let's imagine that our first question was like a test, and we will repeat it again. So 16, 15, where is the fifth? 5, 7? Yeah, that's 3. Okay, let's continue. And the first question. "15 seconds for each question." Yay! Great. The next one. Okay, Renat Akhtyamov, thank you for this. Because he is the head of our local office. So our leaderboard is Ilyor. Okay. Cool. 5 years old. Mhm. Okay. Oh, Aziz, you are the first now. Mhm. Okay. Mhm. Okay, Kirbek, you are closer to the top. Only 7 people answered correctly. Cool. Mm-hmm. 10 people answered correctly. Mm-hmm. Utkirbek, congrats. You are the top. Mm-hmm. Mm-hmm. Cool. Yeah. Mm-hmm. So, Utkirbek, you are our winner for today. Can I help you to bring like our presents? Who is Utkirbek? Okay, cool. No. Ильёр, this one. Так. Это... Сейчас я пишу. Полина, can you just take a photo, please? Thank you for your participation. Thank you for your attention.
Thank you.
So, who is on the second place? Like this? Special branded gifts for you. Who takes photo? And the third one? So what? SS. Okay. Some abbreviations here. Thank you for your attention. And yeah, just a photo. Okay, cool. Thank you guys for all of you to participation, for your interesting questions. And I want to highlight 2 persons who were like the most active with their interesting questions, and let's give them some special prizes too. So Utkirbek, yeah, and your friend, what is your name? Ильёр. Okay, come to us and we will give you special branded prizes just for being active during our session today. Have you counted how many questions like you asked? Because I tried, but it wasn't so easy. Yeah. It is also for you. Some. Any Oh, I received very confidential information about the third person who was really active during the session. Sorry for this. Come here to me and receive your special prize. Yes, thank you. And what is your name? What is your name? Abbas. Okay, thank you. So, and let's spend some time for, I think, appreciations to our today's speakers, Jahangir, Javahir, Polina, Elior, and of course, the first successor, Asledin. Come here to me, and I will share you some special gifts also. Yeah, come here, guys. Don't be shy. Elior. Thank you. This one, here, and here. And the last step of our today's event, let's make a general photo together. So just come on, guys. Everyone should be presented on this photo because it is really historical event for our community. Так, Ильёр, поставишь нам какой-нибудь красивый фон с MJC School? И давайте как-нибудь расставляться по экрану. Давайте на фото все.